Alright, these are some complicated problems that we do in this unit, and I thought I'd make a little video so that you can watch them again and again if you're having troubles. There are some steps to solve these problems. First step is we have a system diagram here. That's this one of what's happening. But we need to draw free body diagrams for the things in the question that are of interest to me. And here I've got a mass hanging down over a pulley and another mass, and this guy is going to pull it down and pull it across. So what forces are acting on M1? I see that there's a mu, so there's going to be some friction. There's always some force of gravity. It's not moving up or down, so I've got to have the normal force, and then I've got tension is pulling this thing. This one, I've got gravity is pulling it down, and T is pulling it up. Yes. Next thing I should decide is which way is the system going, and I hope that everybody realizes that this thing is going to go that way. So the next step says write equations for F net. So I'm going to scroll down. F net. Now it's not moving up or down, it's moving side to side. So, and I know it's moving to the right, so that means that T has got to be bigger than friction, so I'm going to put T minus force of friction. And here this thing is moving down, so it means that the force of gravity has got to be bigger than tension. So we're back up. Sub in F equals MA. Sub in F equals MA. So force is always equal to MA. I'll put M1A equals T minus mu Fn. And here is M2A equals M2G minus T. M1A, what is Fn equal to? From my diagram I know Fn is equal to Fg. And then I also know that Fg is equal to mg. That's a 1. Now I've got two equations. We'll call this number 1 and we'll call this number 2. Each one has an A and a T in it. An A and a T in it. The other things in the formula I know. So I need to solve these two things simultaneously. I can substitute, I can compare, or I can eliminate. I'm going to try to eliminate. I'm going to add 1 and 2. So on the left side of the equal sign, I'm going to put the equal sign here. On the left side of the equal sign I have an M1A, and over here I have an M2A. On the other side I have a T minus mu M1G, and over here I have plus M2G 2 minus T. So I have a T and then a minus T. That means these things go away, and then I can continue to solve. I'm going to factor out A here. I get M1 plus M2. Yes. And I still have M2G minus mu M1G. And now I want to get A all by itself, and so I'm going to divide both sides by this. I'm going to get M2G minus mu M1G all over M1 plus M2. Now M2 is 10 and 5. Oh, wait. M2 is 10. So it's 10 times 9.8 minus 0.2 times 5 times 9.8 all over M1 plus M2, which would be 5 plus 10. And I get 98 minus 0.2 times 4.9 all over 15. And I'm going to get an answer here, and I don't actually care that much about working it out, but I'm getting a number. I'm getting an acceleration number here. And then what we normally have to do in these questions is take this number and go back up here, for example, and plug it in right here. Now I have this, this, I can solve for t. So after I'm done solving for a, I have to solve for t, or if I solve for t first, then I have to go back into one of these equations and solve for a. So let's just review these steps. I have a system diagram. I draw a free body diagram for the things in the question. I write an equation for net force. I write equations for net force for each one. I let F equals ma, and then I solve simultaneously two equations, two unknowns. In math, you've done this many, many times. Okay? And then after I get one, I have to go back and plug in to get the other one. And now there's a second question about sleds, which is very similar. You can watch that video too.